x. Then we will also try to look into this and see how far we can go. This is a clear description of what one should expect tomorrow in your exam. My greatest wish is that we complete the entire question paper 1. So we have 1.1.1 1/2 x into 2x minus 1 being equals to 0. Can somebody tell us what we are going to do then if we want to solve for x? Somebody just to give us a way forward.
So the A distributive, don't do multiplication.
Hey, why do you think we should do distributive multiplication here?
So that we can solve x.
So that we can solve
X.
why distributive? Why do we have to do distributive? Because now I see no need for that.
Half x plus 2x minus 1. Half x plus 2x minus 1.
Since when do we remove the brackets by addition? Since when? Since when do we remove the brackets by addition? That's my question. Since when? Because this is multiplication and multiplication, and this is already equals to 0. We say this 1/2 x equals to 0 or 2x minus 1 equals to 0. Right, I want to give a mona very early in the morning. Very early. Right. 1/2 x equals to 0 or this equals to 0. You never use distributive in multiplication where the two numbers are equals to 0. But if this was 6, then you would remove the brackets by multiplication. But if the number is 0 and there's multiplication in between, 1/2 x multiplies x minus 1, you don't do that. You just say this equals to 0 or this equals to 0. And then we will say here x equals to 0 or x equals 1/2 if you take this to the other side. Testing mihlolo unoyimutsi ngiqala uyibona buphilong manje. Ngikho ngiqala ubona ntwe jwalo buphilong. Right, ke tlo fa chance ya ngola. Ke o ne chance ya ngola ska wa 1.1.2 minus x into 6 minus x equals to 4. Now, because they say you should correct to 2 decimal places, because the number is 4, then you must use distributive law here. Then you will say minus 6x plus x squared minus 4 equals 0. You will write this in a standard form. X squared minus 6x minus 4 equals to 0. And when we write in standard form, we are not changing anything. We are just rearranging in the form of ax squared plus bx plus c. Now, because they said correct to 2 decimal place, you'll never find the factors of 4 that can give you 6. Then you apply quadratic. When we get time, we will show you the derivation of that formula. This is your A, this is your B, and this is your C. The formula says minus, what is the value of B? Minus 6. B, it's minus 6 squared. A, it's 1. Your C, it's minus 4. And we divide everything by 2A. This will give you 6 plus or minus 36 plus 16 all over 2. That will give you 6 plus or minus 36 plus 16, it's 50. 40, 52. 36 plus 16. And then the first x will be 6 plus root 52 over 2. The second x will be 6 minus root 52 over 2. What value do you find with that?
6,61.
6,61. This one,
Negative 0,61.
right, those must be your two values of x. That was a very simple problem to deal with. We go to 1.1.3. We have 2 minus x plus 5 being positive. Now, because this is 0, we calculated the critical values. You equate this to 0. If there was a number here, maybe 6, you will use distributive first, take 6 to the other side and simplify. Then you will say 2 minus x equals to 0, or x plus 5 equals to 0. 2 equals x, or x equals minus 5. Those are your critical values. You will place a negative 1, you will place a positive 1, small and big. Remember what we are saying with this inequality. We are saying the values of x that are positive. Now when you are in here, you will say, all right, once I have found the critical values, let's use a table of values. You will say, all right, minus 5 and 2, I'm moving from negative infinity to minus 5, minus 5 and 2 and infinity. Because it says greater, you will make open brackets because it tells you that minus 5 and 2 are not part of the solution. And then when you are done with this, you will draw up a table of values. In this table, you will place the first one, negative infinity minus 5. You will place the second one, minus 5 and 2. The last one, 2 and infinity. From here, you will say, I'm looking for a value that is smaller than minus 5. The value that is smaller than minus 5 is minus 6. You are looking for a value that is between minus 5 and 2. Minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2. Value that is between this and this. You can take minus 4 or minus 3 or whatever value as long as it is in between. I'm going to take 0. But you can take any value. Value that is greater than 2, that's 3. I will ensure that before the end of today, that video is available on YouTube. There are many in the channel. I've already sent a link into the group. Right. And then from here, you will place 2 minus x. You will place your x plus 5. And the product, the multiplication of those two. You will take your minus 6 and substitute. You will say 2 minus into minus 6. That will give you a positive because you will have 2 plus 6, which is 8. You will take and substitute a negative. You will say minus 6 plus 5. That will give you a negative. Positive multiplied by negative. That will give you a negative. You will substitute 0. 2 minus 0 is a positive. 0 plus 5 is a positive. Positive by positive, positive. You will take 3. 2 minus 3, negative. 3 plus 5, positive. Negative times positive, negative. The answer said that it is looking for a solution where this is positive. Greater than 0, positive. Where do we get a positive? Here. So your solution is minus 5 and 2. That becomes your solution. This is very, very important that you understand. what we are saying there. It's something that will require that you sit down and you practice. Something that requires that one sits down and practice. Right, it's an inequality. But now we find minus 5 and 2. We go and check if this is true. Let me do it on this side. I don't know whether, because when you are here, your teacher might say you have 2 minus x and x plus 5 that is bigger than 0. Your teacher will say 2 minus x is bigger than 0, or x plus 5 is bigger than 0. Your teacher will say 2 is bigger than x, or x is bigger than minus 5. You will draw up a line for minus 5 and 2, and then you will say the values of x that are less than 2. You stand at 2. The values of x that are less than 2 are all those values going that side. You stand at minus 5. The values of x that are bigger than minus 5 are all those values going that side. Where is the solution? At the intersection. This is where your solution is. So meaning your x, remember we are saying the values of x that are greater than 5. In fact, let me do it in this way. Values of x that are greater than minus 5 and values of x that are smaller than 2. Values of x that are greater than minus 5, there they are. Values of x that are less than 2, there they are. Let's check whether this is correct. Let's take in the values of x that are greater than minus 5 and substitute them here. We already saw that the values that are bigger than minus 5, it's minus 4. So let's take minus 4 and substitute it here and see whether we will find a positive number. We will say 2 minus into minus 4. Where we see x, we are writing minus 4. Where we see x, we are writing minus 4. 2, negative by negative, it's a positive. Minus 4 plus 5 is 1. What is 4 plus 5? It's 6 times 1, which is 6. And 6 is positive. It's a positive number. A number that is greater than 0. So the first one is correct, to say that x should be bigger than minus 5. Let's take in secondly now the values of x that are less than 2. Let's take in 1. And let's substitute it there. Now let's substitute 1. We will have 2 minus 1, 1 plus 5. 2 minus 1 is 1. 1 plus 5 is 6. Which is 1 times 6 is 6. Which is also bigger than 0. It's a positive number. So meaning what we have said here is highly correct, because it satisfies the inequality restrictive that you should only have values of x that are positive. So when we arrive here, you can just say minus 5 and 2, and you will be done. Either you go for the table or you go for this. The choice is yours. The choice is highly and highly yours. But this one becomes a little bit simple. This becomes a little bit simpler to work with. That is fine. Let me just give you some time to copy that down so that we can work on that. We can move on to another problem. Let me just provide you with enough time to work on that. How do we solve this? Can somebody just explain to us the procedural methods that are required for solving that? Can somebody help us with that? I'm going to write y plus x minus 10 as my equation 1. and I'm going to write x squared minus xy plus y squared equals 28 as my equation 2. And then I'm going to say from 1, which is y plus x minus 10 equals to 0. And then I'm going to make y the subject of the formula here. Okay, so when uyayibona. Alright, this is equation 3, and then we are going to try and substitute the 3 in equation 2. Equation 2 says that x squared minus xy plus y squared must give you 28. And then from this equation, where I see y, I'm writing minus x plus 10. I see y, I'm writing minus x plus 10. I see y, I'm writing minus x plus 10. That needs to be squared. And this is equated to 28. And then from there, I will have my x squared. Remove the brackets by multiplication. X squared minus 10x. Repeat this 2 times. Equate this to 28. These are like terms. The answer is 2x squared minus 10x plus x squared minus 10x minus 10x plus 100 equals 28. Because positive multiplied by anything is still positive. I don't even have to include these brackets because it will not make any difference. So I can just go straight and group the like terms. 2x squared plus x squared, 3x squared, minus 10 minus 10 minus 10, it's minus 30x. And then I have 100 minus 28 equals to 0. Are we fine? I have my 3x squared minus 30x plus, this is 72. Can you try and check for me whether 3 can go into all of this without leaving a remainder? Can you please divide here by 3 and see if you'll get a whole number? You get a whole number when you divide here and there. Therefore, we will divide everything by 3 to get x squared minus
10 minus 10x.
72 divided by 3.
24.
I will try and factorize this. The factors of 24 that can give me 10, it's 12 and 2. The bigger number takes the sign of the middle term. When I multiply them, I should get a positive. So there's a problem here. I can't use 12 and 2. I can't. Let's try to find other numbers. 24 equals shift fact and provide me with other factors of 24. 2 to power, which is 8 times
3.
icon. 8 and 3 cannot give you 10. Something is not adding up here. Something is not adding up. 100 minus 20, it's 80. 80 minus 80 is 72, yes. But something is not adding up here. Are those only the factors of 24? 8 and 3, 12 and 2. Hey guys. No, something is not adding up. Something is never and ever adding up.
6 le 4.
6 and
4.
6 and 4, yes. Yes, 6 and 4. And then the bigger number takes the sign of the middle term. When I multiply them, I should get positive. So this must also be negative. Negative by negative, positive, minus 6 minus 4 is minus 10. Good. Therefore, x equals 6 or x equals 4. This is my equation 4. Then I will substitute 4 in. Three. And then my equation 3, it's y equals minus x plus 10. I will take the first value, that will be minus 6 plus 10, which is 4. The second value will be 4. Sorry man, this is positive 6. This is 16, and then I will have a 4 plus 10, which is 14. So I have y16 and y14. But this is not 1.2.1, this is 1.2.2. We haven't done 1.2.1. So 1.2.1, we will try and say, they said we should write y plus x minus 10 in the form y equals mx plus c. So we must make y the subject of the formula. So y equals minus x plus 10. So that becomes your 1.2.1. This becomes your 1.2.2. I don't know if this is making sense. I don't know whether this is making sense. 1.2.1, we write this in the form of y equals mx plus c. There it is, the gradient, the value of m is minus 1. The value of the y-intercept is positive 10. And then this is 1.2.2. Find x and y simultaneously. Are we fine? All right. Let's look at 1.3. The formula used to determine the pressure of the fluid, and I have already sent this question paper to you, is shown in the diagram below. Pressure equals force divided by area. Make A the subject of the formula. So they say in 1.3, pressure equals force divided by the area, the amount of space an object will occupy. They say make A the subject of the formula. There are two ways of doing this. You can cross multiply, or you can multiply both sides by A, so that numerator denominator cancels. You have AP equals F. You want to make A the subject, then A equals force over pressure. This is you making A the subject of the formula. I don't know whether we are fine with this. A. Right. 1.3, O2 pressure equals force over area, or to make area the subject of the formula. Right. If I want to make A the subject of the formula, I will get rid of the denominator by multiplying both numerator and both left and right by A. I'll take P multiplied by A, force over area multiplied by A. What I do on the left, I also do on the right. And then your numerator, your denominator, you will go once. Then you have PA here. But remember, you want to make A the subject. You will divide by P. Your area will be force over pressure.
Okay.
Force over pressure. I don't know whether that makes sense. I don't know whether that makes sense. Right. Hauna tab. Let me just give you some chance to copy, because now, to be honest, I can never go down. Down, it's never and ever my thing. Right. In 1.3.2, hence or otherwise, calculate the value of A if P equals, we are given the value of P, which is 25,984. 480,5. P, we are given the value of P, which is in Pascal, and then we have the force. The value of the force is 25 exponent 3 Newton. We are looking for the value of A. We already have force divided by area. Our force is 25 times 10 exponent 3 divided by the area, P, divided by P, which is 25, 984, 480,5 PA. And then what value do we get there? Because I did not include Newton. In fact, let me not do it in this way, so that you may capture this fully. We know that area equals force over pressure. Force, it's 25 times 10 exponent of 3 Newton. Pressure, it's 25, 984, 480,5 pascals. So what is area? Area will be the value of this. I don't know what value you will get there, but somebody will tell us what is 25 times 10 exponent 3 divided by this. Times 10 exponent 3 divide comma 5 0,00
This is the one.
A
09
62
11
27
5
5 Newton per Pascal. This is very, very important. Pressure is this, Newton per Pascal. That will be your area. You can write this in scientific notation as 9,611,275 times 10 minus 1234 Newton per Pascal. This is you writing this in scientific notation. That is you writing that in scientific notation. Let's continue in this. Right, that is fine. That is very, very fine. Let us continue. That was the end of your question 3, because lienze di binary numbers. Skoro. Nizenzi di binary.
1 plus 1 is equals to 1 0.
We will deal with binary numbers as well. Right.
Accepted.
Let me just pause this. We will try by all means to answer the questions that we have before us. And they are just basic problems, to be honest. We will start with 2.1.1. Determine for which values of k will k have equal roots. If the roots are equal, the discriminant is equals to 0. We are saying the roots are equal. The value that is under the square root, that's what we call the discriminant. So meaning 1 minus 3k must be equals to 0. So when k is 1/2, the discriminant will be equals to 0. That's what we are saying there. The discriminant is a value that is under the square root. That value must have equal roots. If the roots are equal, the discriminant is 0. The value that is under the square root must be equals to 0. That's what we are saying. 2.1.2, the values of k for which it will be undefined. Now, if it is undefined, I know that the denominator must be equals to 0. That's when the roots will be undefined. So k minus 4 must be equals to 0, k must be equals to 4. Because anything divided by 0 is undefined. Okay. Alright. And then we go to 2.2. Given the equation for x squared plus 3x plus p equals to 0, if the roots are non-real, then the discriminant is less than 0. The discriminant is negative. If the roots are non-real, the discriminant is less than 0, meaning it is negative. 2.2.2. Find p if the roots are non-real. I have 4x squared plus 3x plus p equals to 0. If p is non-real, the discriminant must be less than 0. We've already said that. Okay? So meaning the value of b squared minus 4ac must be less than 0. So this becomes my a, my b, and my c. My b it's 3, my a it's 4, and my c it's p. This must be less than 0. Alright, this is 9 minus 16p less than 0, 9 less than 16p, p less than 3, 6, 9, 12. This is cannot be simplified. P must be less than 9 over 16 in order for the roots to be non-real. The discriminant, the delta, how to its non-real, how to its real, how to its real and rational, equal, unequal roots, and all of that. You just have to go and look into your notes. So this was our question 2. It's done. Before we can go to question 3, let me allow you to copy down this. Let me allow you to copy down that. And this is how we calculate the discriminant, the delta, the roots of a problem that satisfies a particular condition of interest. We do that.